we're going to go through some trig math here. It's kind of more like trig algebra almost, I would say. So it's how to deal with trig functions in kind of an algebraic sense. So let's say we have sine x plus sine x. Well, something plus something is just equal to 2 sine x. Let's say we have, that's example 1. Plus cos x plus sine x minus cos x. So what we're going to do here is we're essentially going to collect like terms. So what we could do is we could put the sine x's next to each other. And then we can put the coses next to each other. And then we have sine x plus sine x is just, as we said in example 1, 2 sine x minus cos x is minus 2 cos x. Now let's say we have something like tan x times tan x. This actually is going to require a bit more discussion. So it's going to be equal to tan of x squared. But we need a better way of writing it because we don't want to always have to use brackets, and this comes up a lot. So there's essentially two options. So the two options are, so we want to write this. And you might be tempting to say that that's the same thing as this. But it's not, because this is essentially the equivalent of tangent of x squared. So when you put the squared like that, the squared applies to the tangent. So the way we're actually going to show it is we're going to say, we're going to put the squared after the letter. So tan of x squared is the same thing as tan squared x. And that's going to be true for all of the trig functions. So for example, sine x times sine x is going to be sine squared x. And so when we say sine squared, we're saying that the whole sine of x thing is squared. Cos x times cos x is cos squared x. And even for the reciprocal functions, secant x times secant x is secant squared x. Okay, so tan x times tan x is tan x squared, which we're going to write as tan squared of x. 4. So sine x times cos x is just sine x cos x, and there isn't really anything you could do that's all that pretty about that one. So let's say we have tan x times tan x plus 1. And just like regular algebra, what we're going to do is we're going to expand this thing. So we could take the tan x and we can multiply it by both terms in the bracket. And so we get tan x times tan x is, well, now we have our good way of writing it, tan squared x. And tan x times 1 is tan x. Okay, here, same thing, nothing too special. Sine x gets multiplied by both of those two. And so sine x times 2 sine x is going to be 2 sine squared x, because it's 1 times 2 is 2, and sine x times sine x is sine squared x. And then sine x times cos x is negative sine x cos x. It's kind of like if you had like x times y, it would just be xy. It's sine x cos x. Okay. We could do a full FOIL even. So 1 minus sine x times 1 plus sine x. So what we're going to do is the 1's going to multiply by both of those. And it's going to give us 1 plus sine x. And then the negative sine x will multiply by both of those. So negative sine times 1 is negative sine x, and negative sine times plus sine is minus sine squared x. Here we have plus sine minus sine. Those cancel with each other. And so this would give us 1 minus sine squared x. So we have fractions, we want to add fractions. And the way we add fractions is we find a common denominator. And so I didn't actually write it, but this is over an invisible 1. So it's cos x over 1 minus 1 over cos x. And what we're going to do is we're going to say, okay, well, the cos x is going to multiply by cos x over cos x minus 1 over cos x, which is going to be equal to cos x times cos x is cos x squared, or cos squared x, over cos x minus 1 over cos x. And when you have the common denominators, then you could just bring it together, right? It's kind of like 2 and 11 plus 3 over 11 is 2 plus 3 over 11. Well, similarly, what we're going to have is cos squared x minus 1 over cos x. So cos x minus 1 over cos x is cos squared x minus 1 all over cos x. So same idea, another common denominator example. In this case, though, we're going to multiply this one by cos x over cos x. And then this one is by sine x over sine x. And so that's going to give us cos x over sine x cos x plus sine x over cos x sine x. And these may look different, but they are the same. When you multiply, order doesn't really matter. So sine times cos is the same thing as cos times sine. So we have a common denominator here. So we can just add the tops. So that's going to give us cos x plus sine x all divided by sine x cos x. And that is equal to that.